She ate dinner at 9 o'clock every night for 11 years. It wasn't laziness or poor planning. It was the rhythm of their household. Her husband worked late. The evenings were the only time they had together, the table set, the news on, the meal unhurried. For Sylvia, 66, those 9 o'clock dinners were the best part of the day. She didn't know they were also the part most misaligned with her biology. 2 years after she retired, Sylvia noticed something she couldn't explain. She was sleeping the same hours. She was eating the same foods. She was no less active than she'd been before. But her weight had crept up without any change in what she ate. Her fasting glucose, which had been borderline for years, had crossed into pre-diabetes territory. Her inflammatory markers on her blood panel CARP, IL-6, had climbed. And she had started waking at 3 in the morning, lying there for an hour, and going back to sleep, feeling like she'd never really been out. Her internist ordered every test. Every result pointed in the same direction. And then, at a follow-up appointment, her internist asked a question nobody had asked before. What time do you eat dinner? I'm Dr. Ben, and in this video I want to show you what her internist understood and what most of the research on healthy eating completely ignores. Not what you eat. When you stop. Because the last meal of the day isn't just a nutritional event. It is a biological signal. And when that signal arrives at the wrong time, when it lands after the body has already begun its overnight programs, the consequences are more specific, more measurable, and more consequential than most people have ever been told. Let me start with the melatonin that's already rising in your bloodstream before you go to bed. Melatonin is most commonly known as a sleep hormone, but it does something else that is almost never mentioned in a doctor's appointment. It directly affects the pancreas. Pancreatic beta cells, the cells responsible for producing insulin, have melatonin receptors on their surface. Research has confirmed that when melatonin binds to these receptors in the evening, it suppresses insulin secretion. This is by design. The body is preparing for the overnight fast. It doesn't expect food. It is beginning to shut down the daytime metabolic machinery. This suppression typically begins 1 to 2 hours before your habitual sleep time, which means that in most adults, by 9 or 10 in the evening, melatonin is already elevated, and insulin secretion is already reduced. And then you eat dinner. A randomized crossover study published in Diabetes Care, led by researchers at Massachusetts General Hospital, Brigham and Women's Hospital, and the University of Mercia, involving 845 adults, tested exactly what happens when you eat close to bedtime versus earlier in the evening. Each participant had both an early and a late dinner, in random order, while researchers measured blood sugar response over 2 hours. The result, eating close to bedtime when melatonin levels were elevated, produced significantly impaired blood sugar control compared to the earlier meal. The same food. The same person. The same caloric content. The only variable was the clock. And the researchers found something that makes this more serious for a specific group. Approximately 1/3 of the population carries a common genetic variant in the melatonin receptor gene called the MTNR1BG allele that is associated with elevated type 2 diabetes risk. In these individuals, the blood sugar impairment from late eating was substantially worse. Our findings are applicable to about 1/3 of the population in the industrialized world who consume food close to bedtime, the researchers wrote. You don't need a genetic test to act on this, but it does mean that for roughly 1 in 3 people, the metabolic cost of late eating is higher than they realize and invisible without specific testing. Now let me go deeper than blood sugar, because blood sugar is the visible surface of a mechanism that reaches much further. A Johns Hopkins randomized crossover trial compared a routine early dinner at 6 in the evening with a late dinner at 10 o'clock in the same healthy volunteers. The results were more extensive than just blood sugar. The late dinner group showed higher postprandial glucose, confirming the EMUG finding. They showed a delay in the triglyceride peak fats stayed in circulation longer. They showed lower fat oxidation at dinner, the body was less efficient at burning what was just eaten. And their cortisol levels were elevated. Cortisol, the stress hormone, elevated in the evening in response to eating late. And there was a carryover effect. The metabolic disruption from the 10 o'clock dinner wasn't contained to that night. The following morning, the late dinner group showed altered glucose metabolism compared to the early dinner group, the same food, the same sleep, the same next day behavior. The previous night's timing was still affecting them the next morning. That carryover effect is one of the most important findings in modern chrononutrition research. It means that late eating doesn't just disrupt that night, it carries into the next day, altering the baseline from which every metabolic decision the following morning runs. Now here's where this connects to the brain and to everything else this series has covered. Chronic circadian misalignment, the persistent state of feeding signals arriving after the body's biological programs, have already transitioned to night mode triggers a specific set of inflammatory responses. Research confirms that mistimed food intake increases inflammatory markers, including TNF-alpha and IL-6. No single study has run a randomized trial proving that late dinners cause dementia. The research is not at that stage, and I want to be precise about that. But every link in this chain is independently documented. The melatonin-insulin interference is documented. The blood sugar dysregulation that follows is documented. The systemic inflammation that results is documented. The pathway from that inflammation to the brain crossing the blood-brain barrier, activating the brain's immune cells, suppressing the production of BDNF is documented. The chain: late eating, melatonin, insulin interference, blood sugar dysregulation, systemic inflammation, neuroinflammation, suppressed BDNF, cognitive consequences. Every link, independently, and the chain begins every single evening at the moment you eat your last meal. Sylvia's internist understood this. She didn't lecture Sylvia about her 9 o'clock dinner. She asked the question, listened to the answer, and then explained what was happening, what elevated melatonin does to insulin secretion, what that does to blood sugar overnight, what that does to inflammatory markers over months and years. Sylvia was quiet for a moment. Then she said, "So it's not what I'm eating. It's when I stop." That's the reframe. And it changes everything about what the problem is and what the solution requires. Because the solution is not a different diet, it is a different clock. Sylvia and her husband moved their dinner from 9 to 6:30. This was not a minor adjustment, it required changing their evening entirely. He adjusted his work schedule by 45 minutes. She started cooking earlier. They ate before the news instead of during it. It took 3 weeks to feel natural. Sylvia added one other change her internist suggested. If they were genuinely hungry in the evening, which happened in the first 2 weeks, a small amount of protein and fat, nothing carbohydrate heavy, was preferable to lying awake from hunger. The 3-hour rule, finishing the last meal at least 3 hours before sleep, is the clinical benchmark most chronobiologists use. It's not a cutoff of absolute safety. It's the window within which melatonin levels are typically low enough that the insulin system is still functioning with adequate sensitivity. 6 months after the dinner moved, her next blood panel looked different. Her fasting glucose had come down. Her carb had dropped. She had lost weight without changing what she was eating, only when she was eating it. She was sleeping through the night. She told her internist, "I spent 20 years reading about diet. Nobody told me the clock mattered more than the menu." Here is the question to bring to your next appointment. I'd like to discuss my meal timing, specifically the timing of my last meal relative to sleep. Looking at my fasting insulin and carb trend, is there evidence that moving my dinner earlier could improve those numbers? And based on my current metabolic picture, what eating window would you recommend testing first? That question names 2 specific tests already in a standard metabolic panel fasting insulin and carb, and asks for a personalized recommendation rather than generic advice. A physician who sees an upward trend in either will immediately recognize the connection to meal timing. And framing it as a test, what window would you recommend testing, first turns the conversation from passive to active. You're asking for an experiment, not just an opinion. In the next video, I want to do something we haven't done yet in this series. Rather than looking at one more thing that's harming the aging brain, I want to focus entirely on the bacteria that seem to protect it, specifically the ones found consistently in the gut microbiomes of people who reach 100 years old, across populations that share almost nothing else in common. There is a specific compound these bacteria produce that most people over 60 are no longer making in adequate quantities. And recent research suggests it may be one of the most important things you can give your brain, not through a supplement, but through the ecosystem that makes it. Subscribe so you don't miss it. And if your household eats dinner late by habit, not by choice, but because it's simply how the evening runs, share this with the person who controls the kitchen clock. I'm Dr. Ben. I'll see you in the next one. The information in this video is for educational purposes only and does not constitute medical advice. Always consult your doctor or a qualified healthcare professional before making changes to your diet, meal timing, or health management plan.